Hi everyone, welcome or welcome back to my channel. So in today's video, we are going to solve a question of LeetCode that is based on binary search and answers. So we're first of all going to read out the question and then we'll start thinking about the brute force approach and we'll try to optimize it. So let's see what question says. So we have been given a non-negative integer x and we have to return the square root of the number. And we can also round it down to the nearest integer. Now let's say we have been given a number 16 and we have to find the square root of 16. So we can clearly say that its square root is 4, so we can return that. But if the number is 8, then actually its square root is 2.82, but we can return 2 in that case because we can round it down to the nearest integer. It is clearly mentioned in the question. Now, if I try to calculate the square root of a number, we can think about a brute force approach here. Okay. Then let's say we have a number 36, then we can iterate from 0 to 36 and we can check for each and every number if its square, let's say if I into I, if that is let's say less than equal to n or not, then we can store it inside our answer. Suppose I'll try to code the brute force one at first. So I'll be initializing my answer as 0. Then I'll run a loop. From 0 till, now here I'm going to do one thing. I'll be running the loop till I into I that is less than equals to n, which is our target. Okay, here we have x. I plus plus. Now we'll be storing the value of I in our answer variable. Then we'll return this. Now the reason of doing this is that suppose if we are getting a particular square root, actually square root we are getting, let's say for 16 we are getting 4. So ultimately when I will reach to 4, then 4 into 4 is going to be equal to 16. So here only we'll be getting the updated value of our answer, so that will return that. Let me try to submit this code. Okay, it's accepted, but this is not an ideal solution if the number is too big. Okay. So there we'll be using the binary search. Now, how can we think that binary search can be used here? Now, in square root or squaring, we are basically playing with numbers, right? Now, suppose we have to find out the square root of something, we can clearly think that suppose 36 is our number. Okay. Then we know very well ki chalo 6 is the square root of 36. Now this is always true that any number which is going to be greater than 6 वो कभी भी 36 के equal नहीं होगा. So we can easily eliminate the right hand side of 6, all the elements. We can also say that a number less than 6, that is let's say 5 or 4 or 3, so the square of those numbers are never going to be equal to 36. So we can there also eliminate the left hand side. So if the elimination comes into the picture, we can always think about the binary search. And in this question, I've also tried to show by using dry run. Suppose we have a number as 36. Wait. Suppose we have a number as 36. So we clearly know one thing, that the square root of 36 is going to be lie between 1 and 36 itself. So we have also got a sorted range. Now whenever we get a sorted range of something, we can use binary search here. So that's what we have tried to do. Now first of all, we'll be finding the mid. So mid we are getting here 18 in the case of 1 and 36. Now we'll ask the question to ourselves. Now suppose we picked up a number 18 and we are assuming that 18 can be the possible square root of 36. We don't know the answer yet. We are just assuming it to be the square root of 36. Now we'll just verify it. First we'll ask that is 18 into 18 equal to 36? No, it's not. It means it's not the square root. Now we'll check कि अगर 18 हमारा स्क्वायर रूट नहीं है तो क्या वी शुड चेक ऑन इट्स राइट हैंड साइड और वी शुड चेक ऑन इट्स लेफ्ट हैंड साइड. Basically we are going to figure it out कि which part we have to eliminate from now. So we'll ask one more question. Is 18 into 18 greater than 36? In this case, yes, it is. So अगर 18 का square it's greater than 36, for sure 19, 20 and so on, all the numbers on the right hand side of 18, that is also going to be greater than 36. So here we can easily eliminate the right hand side. So this is what we have done here. Right hand side को हम लोग यहाँ पे eliminate कर देंगे and we'll shift our end to mid minus 1. That boils down to 17. Okay. So we got a new range from 1 to 17. Now this is how the binary search helps us. इसमें हमें पूरे के पूरे iteration को करने की जरूरत नहीं है. Here our search space is reduced to half. So now we have to search only from 1 to 17. Now in this case our mid is coming out to be 9. Again we are assuming that 9 can be the square root of 36. So again we are going to verify. Is 9 into 9 equals to 36? No, it's not. Now we'll ask that कि क्या 9 का जो square है वो 36 से बड़ा है? If yes, then we'll eliminate that half. Now here also we can see 9 का जो square है that is coming out to be greater than 36. It means कि 10 का भी square बड़ा होगा 36 से, 11 का भी बड़ा होगा, and all the numbers after 9 that is going to be greater than 36 for sure. So here also we are going to do this thing. We are going to eliminate the right hand side. All the elements to the right of 9 we'll be cancelling it out. So again we'll do end is equals to mid minus 1. So our search space again it boils down to 1 to 8. Now here also we are going to find out our mid, that is going to be 4. Now here we are assuming that our square root can be 4. So we'll ask the question that is 4 into 4 equals to 36? It's not. Is square of 4 greater than 36? No, it's not. It means square of 4 is less than 36. So अगर 4 का square 36 से छोटा है, it means all the numbers less than 4, even they are also going to be, even square of those numbers are also going to be less than 36. So here also we can clearly eliminate the left hand side, and we are again left out with the right hand side of the mid. So we have reduced our search space. And our range is from 5 to 8. Then our new mid is 6 over here. Then we'll ask a question that is 6 our possible square root of the given value, that's 36. So we'll ask that is 6 into 6 equals to 36. Then here we are getting it. So our answer is going to be 6. Now I hope you guys understood the dry run. Now let's move towards the code and write it down. So this was the brute force code. So it's good, but it's working, but we should optimize this one. So let's move to the binary search code. Now, as we did here, we are going to take the search space initially from we're going to take the search space from 1 to n. Okay. I mean x over here. So let's say s is equals to 1, e is equals to x. Then one more thing which we are going to do here is we'll be writing here a base case that if n, or you can say like this is a possible scenario that if the number x, if it's 1, then its square root is going to be 1 only. So if x is equal to 1, we'll be returning 1. After that, we'll be performing our binary search while s is less than equals to e. We'll keep on calculating our mid. Now the reason of writing this formula for mid instead of s plus e by 2, because it somehow reduces the time complexity. So it's better if you write this instead of s plus e by 2. Then what we did after finding the mid, we were checking the possibilities. Now, finding mid was something that we assumed that this can be our possible square root. After assuming the mid, we were trying to basically check the possibility. So this is what we are going to do over here. If mid into mid. Now here while I was showing three possible cases: equals to, greater than, or less than. But in the question which we have been given here, it has clearly mentioned that we can also use the floor value, or we can also use the rounded off value if the square root is not present. So here what we are going to do, अगर let's say mid का जो square है that is less than equals to the answer, sorry, that's less than equal to x, it means we can consider it as a possible answer, because maybe इसके बाद हमें सीधे greater than x मिल जाए, तो at least we should have a particular floor value stored with us. So this mid is going to be our answer, and we can also explore to the right hand side of that number. So s is equals to mid plus. Else, if the case is opposite, that let's say square of mid is coming out to be greater than x, it means all the numbers to the right hand side of mid is going to be greater than x. So we'll just do n equals to mid minus 1 and we'll return our answer. Okay, I've not declared the answer. Wrong. Okay, so it's accepted. Talking about its space and time complexity, so it's not consuming any extra space as such, so that will be constant. And for time complexity, we are basically the search spaces of size x here, so we can say that it's log of x because we are using binary search. So yeah, this was all about this question. I hope you guys understood whatever I tried to explain. Thank you so much for watching.